1.3 here, we are looking at the real number system and the number line. This video may get a little bit long because 1.3 covers many different topics, but I will try to keep it as short as possible. And keep in mind, we will most likely spend multiple days in class on this topic. So the first distinction that one has to make with the real number system is between our rational and irrational numbers. So we represent rational numbers with a Q and irrational numbers with an I. So starting with rational numbers, a rational number is any number that can be written as a fraction or a terminating or repeating decimal. A terminating or repeating decimal means that the decimal ends. So we would have something like 1.62, or it repeats, which would be like 1.666, repeating forever. And then obviously a fraction would be something like 4/3. Okay. On the other side, we have irrational numbers. Irrational numbers are any number, number that cannot be written as a fraction or, what's going on here? Delete. Got it. Or a terminating / repeating decimal. Sorry about those troubles with the pen there. Hopefully it works better now. So examples of an irrational number, we could have pi, which if you wrote that as a decimal would be 3.14159, so on and so forth. It never repeats, it never terminates. It's just a gross decimal. Another example of this would be the square root or cube roots of a non-perfect square or cube. So if we took the square root of 2, square root of 31, square root of 80, all of those would give you non-terminating or repeating decimals. All right, continuing down the list here. The next section, we have integers, which is represented by a z. An integer is a more specific version of our rational numbers. So really, I would think of this list as two categories. We have the left side, which is the numbers that we commonly work with. And then we have irrational numbers, which is kind of on a side by its own. But more specific than a rational number is an integer, which is any positive or negative whole number. Right? Examples of this would be -3, -2, -1, 0, 1, 2, 3, so on and so forth. Keep in mind it's just really any whole number, positive or negative. W represents our whole numbers. Oops. Okay, our whole numbers only account for positive numbers and 0. Okay, that is the important part about whole numbers. So whole numbers do not account for negatives like integers do, but instead it starts at 0 and works its way positive. Keeps going forever. Finally, the most specific set of numbers that we'll work with for now are the natural numbers. Okay, a natural number is a positive whole number. It does not include 0. So, similarly to whole numbers, we go 1, 2, 3. We'll continue positive, but keep in mind it does not include 0. So hopefully you guys have this entire list written down here. This is our real number system. We will quiz on this. We will test on this at some point. So it is important that you guys are starting to learn the terminology, study it a little bit, and make sure you know a couple of examples. All right, moving on to some vocabulary. You guys will have to know all of this for the school year. So a set is a well-defined collection of objects. A set is represented by these two bracket symbols. So an example of a set would be if I would give you the set of 1, 2, 3, 4. So it would be a collection of objects, which would be those 4 numbers. An element is each object within the set. So in this case, 1, 2, 3, and 4 would all be elements. A subset is elements of a given set. So if I wanted to make subsets from my original set, I could take 1 and 2 and make those a subset. I could also take 2 and 3 and make those a subset. It's essentially just breaking up a set. So I know in the last video we talked a little bit about squaring. So the opposite of squaring is a radical. A radical essentially undoes squaring. An example of a radical of a perfect square would be the square root of 4. We're going to work with radicals a lot later in the school year. So let's just go over our perfect squares. This is a list that is super helpful for you guys to keep around and refer back to, especially once we start working with radicals. So the reason we call these perfect squares is because if you were to take the square root of these numbers squared, you would get the original number. So to square a number, you will multiply the number by itself. That's why the square is here. I could do 1 times 1, which would give me 1. So 1 squared is just 1. Okay, you could continue this process. 2 squared would be 2 times 2. 2 times 2 gives me 4. So then I have 4. Okay, I'm not going to keep using the square. If it's a nice visual for you, please use it. 3 squared would give me 9. 4 squared is 16. 25. 36. 49. 64. 81, and 100. Okay? This perfect squares, these are important for you guys to memorize, learn, and know for the school year. We will use them all the time. All right, continuing on to, the second page here. We are going to take a closer look at some radicals. Zoom in a little bit. So taking a look at radicals, okay, remember radicals undoes squaring. So if we were to take the square root of 81, look at your perfect squares list that we just made. A perfect square for 81 would be 9 squared. So the square root of 81 is just 9. Similarly, with fractions, you would square root the numerator and the denominator separately. So the square root of 1/16 is just the same as saying the square root of 1 over the square root of 16. Well, now ask yourself, what number squared gives you 1? That is just 1. And what number squared gives you 16? And if you guys look back at your list, you should see that that number is 4. All right, I'm going to let you guys do that last one on your own. Remember, break up the numerator and denominator first, and then take the square root of both numbers. Sometimes, though, we will not work with perfect squares. So when we work with non-perfect squares, that is when we have to simplify to the nearest integer. We're just taking an educated guess. Well, not really. We're just simplifying our original square root. So starting with 45 here, we ask ourselves, what are factors of 45 that could include a perfect square? Well, on the top of my head, I'm thinking, we have 1 times 45. That doesn't really get us anywhere. But it ends in 5, so I'm instantly thinking 5 times what? And in this case, it would be 9 times 5. I'm going to rewrite that actually. It doesn't look too great. So we have 9 times 5, which equals 45. So essentially, we are just breaking this up into 2 parts. From here, we can separate that radical to be the square root of 9 times the square root of 5. Well, luckily for us, 9 is a perfect square. So what number squared gives us 9? Well, that would be 3. But unfortunately, 5 is not a perfect square, so we would just leave it as the square root of 5. And that is how you would simplify that radical. Okay, we're going to work a little more on that process in class. We will leave that bottom radical for class. Try to simplify it on your own. Might be a little bit difficult at first. All right, the very last thing here is this number line. I think this would be a really good one to save for class to do together. Why don't you guys try this on your own first? The one thing to keep in mind is to get the best placement, you would want to simplify your radicals and simplify your fractions if possible. But please write these numbers down, draw in a number line, doesn't need to be labeled, and give it a try. All right, thanks for watching. I know that video was a little bit long and it had a lot of different parts to it.